Hi guys, so welcome to our today's class of statistical mechanics, right? तो अभी तक हमने क्या क्या देखा? हमने देखा कि the few thing first thing we are looking this statistical physics course, right? And mostly mechanics, right? तो उसमें idea क्या था कि हमने the first concept that we are into that's basically your entropy. Entropy हमने दो definition देखी. That's one the Kelvin statement and the other is Clausius statements, right? Kelvin's and Clausius. और इन दोनों का स्टेटमेंट ही जस्ट वन थिंग कि देयर आर स्पॉन्टेनियस प्रोसेसेस व्हिच प्रोसीड्स इन वन डायरेक्शन और जो द क्वांटिटी दैट गवर्न दिस चेंज इज बेसिकली एंट्रोपी. एंट्रोपी का जो डेफिनेशन है वो बेसिकली जो द फंडामेंटल डेफिनेशन दैट वी आर गोइंग टू इंटरेस्टेड इन दैट्स बेसिकली बोल्ट्जमैन डेफिनेशन में हम इंटरेस्टेड हैं. और द बोल्ट्जमैन डेफिनेशन क्या है बेसिकली दैट्स बेसिकली गिव्स यू the definition of entropy in terms of accessible states of a system. So basically S is basically your log of accessible states, where we will see how we calculate the number of accessible states. That's वही पूरा टारगेट है कि accessible states को calculate कैसे करना है. तो अगर आपके पास कोई मॉडल सिस्टम है, let's when I say states of a model system, right, the way it is written here, states of model system, what it means, what do you mean by model system? तो मॉडल सिस्टम क्या हो सकता है, राइट? द वे आई डिफाइन अ सिस्टम हियर इन दिस वे, द सिस्टम इज डिफाइंड अ सिस्टम ऑफ एन स्पिन्स, राइट? एन स्पिन है. अभी स्पिन्स क्या हो सकती है? स्पिन्स कैन कम फ्रॉम द आउटर कॉन्फ़िगरेशन ऑफ एनी एटम, राइट? और बट इट्स द वन थिंग इज दैट द स्पिन इज प्रीटी, ऑल्दो कि स्पिन जो है वो मोस्टली एक क्वांटम कॉन्सेप्ट है, लेकिन बट द वे वी आर यूजिंग इट हियर इज जस्ट showing a discretizations of things and the accessible states of a system, right? तो उतना सा आइडिया है. we are not very much into quantum picture and anything like that. तो बस जस्ट n स्पिन्स हैं और स्पिन्स का प्रॉपर्टी ये है कि दे कैन स्प्लिट इन ए बाइनरी वे, लाइक या तो अप करेगा या तो डाउन करेगा. देयर इज नो अदर वे अराउंड. सो इस दिस सॉर्ट ऑफ सिनेरियो यू आर आल्सो गोइंग टू स्टडी इन द Ising model. So but right now I'm not I mean giving you anything regarding the detailed aspects of Ising model, but this is the basic idea of a model called basically Ising, or whatever you want to pronounce. It's a Ising model, right? तो अभी क्या आइडिया था कि लेट अस कैलकुलेट फॉर टू एटम कॉन्फ़िगरेशन कि हाउ मेनी नंबर ऑफ एक्सेसिबल स्टेट्स यू कैन हैव, राइट? बिकॉज क्योंकि हमें एंट्रोपी कैलकुलेट करना है एंड एंट्रोपी कैलकुलेट करने के लिए वी नीड टू हैव नंबर ऑफ एक्सेसिबल स्टेट्स. तो अभी इस केस में अभी लेट्स सी या तो अभी जैसे फॉर टू एटम कॉन्फ़िगरेशन यहाँ पर जैसे लिखा गया फॉर टू एटम कॉन्फ़िगरेशन, सो you have a number of atom 1 here, you have number of atom 2 here. So you can see that the way binary configuration is defined, that the atom 1 can exist either up or atom 1 can exist either down. Similarly for atom 2 can exist either up or atom 2 can exist down. So the total number of configuration would be the product of these two, right? तो अभी क्या क्या, so out how many things you can construct out of this, right? पहला तो ये हो जाएगा up है, दूसरा है up down up 2 right? So you see you can always label them the particle 2 these are the product that you can get from like up down up down, right? So all sort of, so here I just written number of configuration. You can see there are 4 configurations out of it. For 3 atom configurations you can similarly break it down up down and then calculate all sort of scenario. तो पहला जब all up है with one down, one, you can see there is a one down, there's a one down, there's a one down, right? And when there are 2 down, you can see there are 3 configuration. When there are all down, you can see there is 1 configuration. So iske corresponding, jab they are all up, there is just 1 configuration. When there are 1 up and 2 down, there are basically 3 configuration. यहाँ भी 3 configurations हैं, यहाँ पर भी 1 है, तो 3 3 6 2 8, total number of configurations will be 8, right? So but how about these are 3 atoms? I said you can calculate for 4 atom configurations, or let's say for an n atom configuration. तो अगर अभी n atom configuration लिखेंगे तो कैसा आएगा, right? That's what you want to see if you want to write n atom configuration. So n atom configuration, that's what we just we restrict ourselves, but the number of configuration I give to you idea, right? For here there's a logic behind it. Like you can see 2 square, here you can see 2 to power 3. So it's because the binary model system, you can guess that this will be something like 2 to power n, right? For n atom configuration, the number of accessible state how will be 2 to power n, right? That's your important takeaway from this thing, right? तो अभी दो आइडिया था वो कुछ ऐसा था कि how do you calculate the magnetic moment of such system, right? So system is defined over here. So this is your system. System is consist of n sort of spins, right? There are n spins, and the idea is basically all can be up or all can be down, or either one can be up or maybe whatever the combinations you can get possibly think of. Just the one restriction कि या तो ये up होगी या तो down होगी. तो total magnetic moment of such n particle system आप कैसे लिखोगे, right? तो अगर सभी स्पिन्स अप हो जाएं और एक स्पिन प्लस म्यू कंट्रीब्यूट करे तो फॉर n spins it, that's obvious, right? n mu when all up, that's the situation. So you can get this total magnetic moment n mu when all spins are up. Similarly, you can get total magnetic moment minus m mu when all spins are down, right? That's the idea, right? Abhi there could be one interesting scenario that's here in the question, that the calculate magnetic moment when one spin down. अभी एक स्पिन डाउन हो गया और तुम आपके पास सिस्टम ये है, द सिस्टम इज समथिंग लाइक दिस. हाउ डू यू कैलकुलेट द मैग्नेटिक मोमेंट ऑफ सच सिस्टम व्हेन वन स्पिन इज डाउन? सो you can see that that's is pretty obvious, right? Because you have n particle system, and when one spin is down you are left with n minus 1 spin up, right? So the total magnetic moment with n minus 1 spin which are pointing in the positive direction, तो n minus 1 जो कि up की तरफ है तो n minus 1 mu contribute करेंगे, और 1 which is down with contributing minus mu, so there is n minus 2 mu. So the total magnetic moment will be n minus 2 mu. देखो general notion what you will have that कि एक spin down हो गया तो n minus 1 mu हो गया, but you have to really take care, right? वो तो सोचना पड़ेगा कि n minus 1 है वो जो कि प्लस में कंट्रीब्यूट करेंगे, and there's a one additional which is contributing minus में, so total n minus 2. This is basically even separation that will comes out from these things that you have to take care of, right? अभी 2 spin down है जैसे इस केस में तो क्या होगा, तो n minus 4 में, right? तो अगर अभी मैं कहूँ कि अगर इसी तरह मतलब अगर 3 spin down है तो क्या हो जाएगा, तो n minus 6 mu, right? On so on. अगर सभी spin down है तो n minus n mu, right? That's the basically takeover from this. अभी हमने देखा कि for two binary model system, for a single particle, I mean for a 2 particle binary system, right? The number of accessible states are something like this, right? Where basically you can write it down something like this. For a 3 particle system it is something like this. So total number of states were 4. Here it was 8. Here the idea is to calculate for this sort of thing, right? When there is a n particle system. So you will notice that these are basically 2 sort of species which is governed by x or y number. X and y can be anything, that it's up or down. इस केस में आपके केस में up है और y जो है down है. But consider the binomial expansion of x plus y to power n. So this is x to power n and x minus n y per 1 y to n and minus 1 factorial and so on, right? तो इसको आप इस तरह से लिख सकते हैं nct x for with the t suffix, right? तो t रन करेगा over all species और ये आपका total nct आ जाएगा, right? So now you will see that for if I replace t with something like n by 2 plus s, where s is basically I will say for logical reason is a spin excess is associated with spin excess, which is basically an integer, right? तो अभी देखेंगे वो उस केस में क्या होता है when t basically n plus 2 by s, then the number of up spin basically n plus 2 by s, and number of down one is basically n plus 2 minus s. So the total number of particle with up minus total number of particle with down will be how much? 2s, right? So s is basically, this is called the spin excess, right? This is called basic, s is called basic, 2s is associated with the spin excess. तो अभी देखेंगे कैसे निकालते हैं उसको. तो but you see that for the n particle system you can see that the way you can get number of states is something like the binomial from the binomial expansion, and where I define a function g and s, which is a function of, and this is basically the multiplicity function. So this function defines the number of states having the same value of s, right? That's what the idea. For n particle system, the number of states with the spin s is something n plus 2 plus s, and n by 2 minus s with the number down, and n up is something this, and up and down is something this, where S is associated with the spin axis. So this is your takeover for today's class, and we will see that how this GNS, basically this multiplicity function, which we call GNS, this multiplicity function will lead to the Gaussian function for very large n cases. And this is very interesting result, because once you know that basically the idea to that you reach choosing particle from out of given number of species, and that choosing will lead you to the Gaussian set of distribution in probability theory. तो आज का class, let's find it out here, and stay tuned for further information. Thank you for today's class.